Today's lesson is covering measures of center. There are 4 measures of center that we're going to be talking about today: the mean, the median, the mode, and the midrange. The mean is the average of the numbers in the data set. In other words, we're going to add the data values together and then divide by the number of numbers in the set. The median is the number in the middle. So in order to find this, we're going to order the numbers from least to greatest and then locate the number that's in the center. If there's an odd number of numbers, there will be one number in the exact center. But if there's an even number of numbers in the data set, you'll have to find the 2 numbers that are in the middle, and then we average those 2 numbers together. In other words, add them up and divide by 2. The mode is the number that occurs the most. And then the midrange is the low number plus the high number divided by 2. In other words, it's the average of the minimum and maximum numbers in the data set. So let's take a look at an example, and we're going to calculate these 4 measures of center using this example. So it says the ages and weeks of a random sample of 6 kittens at an animal shelter are 3, 8, 5, 12, 14, and 12. We're going to find those measures of center, again, using the formulas or the definitions. So in order to find the mean, we're going to add the numbers together. So 3 plus 8 plus 5 plus 12 plus 14 plus 12. Once we find this sum, then we're going to divide by the number of numbers in the data set. This data set has 6 numbers in it, so we're going to divide by 6. If we add those numbers together, I've done that on the right on my calculator, I got 54, and we're going to divide that by 6. That gives us a mean of 9. All right, the next measure of center that we're going to do is the median. In order to find the median, we first need to order the numbers from least to greatest. So 3, 5, 8, 12, 12, and 14 are these numbers ordered. Notice that there's an even number of numbers in the data set, so there's not going to be one number in the exact center. Instead, I have 2 numbers in the middle. So we're going to average these 2 numbers together. So I'm going to add 8 plus 12 and divide by 2. So we get a median of 10. The mode is the most frequently occurring number in the data set. There's only one number that occurs more than once in this data set, and it's 12. You could have no mode for a data set, or you could have more than one number that's a mode for a data set. All right, the last measure of center is the midrange. The lowest number, or the minimum, is 3, and the maximum number, the highest number, is 14. So we're going to average these 2 numbers together. Add them up and divide by 2. So we get 17 divided by 2, which is 8.5. So the mid-range for this data set is 8.5. Now, we can also find these measures of center using the graphing calculator. Well, at least some of them. We go to Stat and enter on Edit, and we enter these numbers into List 1, which I have already done. Then we go to Stat and Calculate, right arrow over to Calc, and the very first one var stats, is what we want. We do have the numbers entered in List 1. That comes up by default. However, if it's not there, you can push second 1 to get List 1 there. The frequency list, we do not have a frequency list. All of these numbers are just occurring once, so we're going to leave that blank. And we are calculating. Okay, we see the very first value that pops up, x bar, that is the symbol for mean, sample mean. So our mean is 9, which is what we got using the formula as well. If we scroll down a little bit further, MED, that's the median. The calculator will not calculate the mode or the mid-range for us. However, it makes finding the mid-range a little bit easier because it does tell us the min and the max. So again, therefore, we would just add the 3 plus the 14 and divide by 2. This menu will give you a lot of other measures that we'll be covering a little bit later. Okay, next example, we're going to take a look at an example that is a stem and leaf plot. So we see from this stem and leaf that the key down here says 5 line 4 is equal to 5.4. So the numbers in the data set would be 5.4, 5.4, the next one is 6.2, another 6.2, so on and so forth. Okay, I'm going to go ahead and enter these data values into my calculator. Again, going to Stat and Edit. To clear the previous list, we're going to highlight List 1 and push Clear, Enter. Okay, I've entered those numbers into List 1. I'm going to go to Stat and Calc. Again, 1 var stats is what I want. I just have the one list, so I'm going to calculate. The very first one that we see there is the mean. I'm going to round this to 2 decimal places. So my mean is 6.63. The median, if I scroll down on the screen, the median is 6.45. The calculator does not tell me the mode or the mid-range, so I need to look at the data set and determine which numbers appear the most. So I see 4 numbers that occur twice. So I would have 4 modes here: 5.4, 6.2, 6.4, and 7.2. All of those numbers appear twice in the data set. All right, the mid-range, again, is the minimum value, 5.4, added to the maximum value, 8, and divide by 2. So that gives us 13.4 divided by 2. And if I do that, 13.4 divided by 2 gives me 6.7. So 6.7 is the mid-range. All right, this next example is a frequency distribution. It is representing the grades on a 4-point scale of 25 students in a college math class. Again, we're going to find the measures of center. But first, we need to understand how to read this frequency distribution. So the first score is a 0, which would correspond to a grade of F. And we see that the frequency is 2. So this means 2 students in the class scored an F, or a 0. 4 students in the class scored a 1, or a D. 12 students had a C, or 2. 4 students had a 3, or a B. And 3 students had a score of 4, or an A. So if we add up those frequencies, those should add up to the total number of students in the class, which it was said earlier that there were 25 students. So I'm hoping if I add those frequencies together, I would get a sum of 25. Okay, we're going to go ahead and find the measures of center using the calculator. Stat and Edit. Again, clear the list by highlighting List 1 and pushing Clear, Enter. We're going to go ahead and enter the scores into List 1 and then the frequencies into List 2. So now we have what's called an X list or a data list, list 1, and we have a frequency list, list 2. So now when we go to stat and over to calculate, we're still going to choose the one var statistics, but now we do have a frequency list. So I'm going to down arrow to where it says frequency list, and I'm going to hit second 2. So my X list, my data list, is list 1, and my frequency list is list 2. Now I'm going to go ahead and calculate. All right, the mean for this data set is 2.08. I'm just going to round that to 1 decimal place this time, so the mean is 2.1. The median, if I scroll down, the median is 2. Again, the calculator does not tell me the mode. However, in a frequency distribution, it's easy to find the mode. Look for the number that has the highest frequency, and then the number that's associated with that is the mode. So again, remember there's 12 2s in the list. So 2 is my mode, or number that occurs the most. It occurs 12 times. And then the mid-range is the low score, which is 0, plus the high score, which is 4, and divided by 2. So we have 4 divided by 2, which is a mid-range of 2. Notice all of the measures of center for this particular data set are very close in value. They're all about 2. So this is a distribution that we would call symmetric. We'll be talking about shapes a little bit later in the notes. Another way that we can organize data is a grouped frequency distribution. So this is an example of a grouped frequency distribution. We see that on the left side, we have values between 16 and 20. This is representing class size. And again, we have frequency. So we know that there are 3 data values that are within the range of 16 to 20. We don't know individually what they are, so they could all be 16s. All 3 data values could be 16s. All 3 data values could be 20. Or there could be a mixture of values in between 16 and 20. Again, there's 5 data values that are within the range from 21 through 25, so on and so forth. Now, it's impossible to enter a range of values in your calculator under a list. So we have to determine what would be the best measure to represent those ranges. So if I know I have 3 data values in the range from 16 to 20, I don't want to put them all as 16 because then this might be a low estimate for what they really are. And I don't want to put them all at 20 because this would be a high estimate of what they are. So what I really want to do is I want to determine what number is in the exact center of that range. In other words, I want to find the midpoint. So I am going to add 16 plus 20 and divide it by 2. I'm basically finding the average of those 2 numbers. And I see that the average is 18. So 18 is in the exact center, and it would be the best estimate for those 3 numbers. Okay, so 18 is the number that I'm going to use to best estimate that range of values. This is called the midpoint of that class. All right, if I do the same thing for the next group, 21 plus 25, and again, find the average, divide by 2, and the midpoint is 23. I could continue averaging those numbers, but also I see that these are increasing by 5 each time. So these midpoints will also increase by 5 each time. So I could just continue the pattern. 28, 33, and 38. All right, so this is what we call the midpoint of x, and that is what we're going to enter into our calculator. That would be the best estimate for each of those values. Okay, I've entered those numbers. I'm going to go to Stat, over to Calc, and 1var Stats. Again, I have both a list 1 and a list 2, and I'm going to calculate. The mean is 26.8. The median, I'm going to scroll down, is 28. The mode, the number that occurs the most, this group occurs the most, 21 through 25. It occurs 5 times. So 21 through 25. This is called a modal class. Okay, because I don't really know what those 5 numbers are, but I know they're within that class, 21 to 25. So instead of seeing mode, you may see modal class. Same thing with median. Sometimes they'll ask for median class. So if I look, the 28 is in the class from 26 to 30. So if you're asked for a median class, you want to give the range of numbers rather than just one number. Okay, and then the modal class, 21 to 25, and then the mid-range, again, I'm going to add the lowest possible number plus the highest possible number and divide by 2. So I would get 56 here divided by 2, and that would be 28. Okay, the next thing we're going to cover is what's called the weighted mean. And it's the mean of a data set in which all of the values are not equally represented. So there's a formula that's on your formula sheet that we're going to be using to find this weighted mean. We're going to take the weights times the x values, sum those together. This Greek letter sigma stands for the sum of w times x, or the weights times the data values. And then we divide by the sum of the weights. Okay, so taking a look at our first example, we see a student received the following grades and credits in their college classes. We want to find the student's GPA, which GPA is grade point average. So we're asked to find the weighted mean for the GPA, or the weighted grade. Okay, so we see that this student has 4 classes: English Comp, Intro to Psych, Bio, and Phys Ed. The credits, so each class is not weighted the same. The Bio class is worth more than the Phys Ed class. It's weighted higher. Okay, and we see the English Comp and the Intro to Psych are both weighted with 3 credits. And then we see a grade of A, C, B, and D. We're going to convert these grades to the 4-point scale. So if we think of the 4-point scale, an A is a grade of 4, a C is a grade of 2, a B is 3, and a D is 1. Okay, so rather than thinking those letter grades, we're going to be thinking about what those grades represent on the 4-point scale. So when we enter this into our calculator or use the formula, we have to be very careful what is representing the data value and which one is representing the weights. Since we want weighted mean of the GPA, of the grade becomes the x values, and the credits become the weights. So when you're reading these questions, ask yourself, what are they asking me to find the mean of? Whatever that variable is, that is going to become your x variable. And then the other one will be the weights. Okay, using the formula, I am going to multiply the weights times the x values. So I'm just going to multiply straight across here. So 3 times 12, that gives me 12. 3 times 2 is 6. 4 times 3 is 12. And 2 times 1 is 2. We are then going to add those products together. So if I add those, I get 32 as the sum. So looking at my formula, the sum of the weights times the x values is what we just found. That's 32. And then I need to make sure I'm dividing by the sum of the weights. The weights are kind of like the frequency here. Okay, so when we were finding mean, we wanted to divide by the number of numbers in the list. And that would be the sum of the frequencies, or the sum of the weights. So in this case, we're going to sum the credits together, and this is the value that I'm going to divide by. So if we add this column here, I get a sum of 12. So we're going to divide that by 12, and this is going to give me the mean. So 32 divided by 12, this student has a 2.67 GPA. That is what's called a weighted mean. Then it kind of looks like a frequency distribution because we have x values and we have frequencies or weights. All right, looking at another example, in a math class, your grade is calculated using percentage weights. Find this student's grade in the class. Again, we want to find the student's grade, so grade becomes the x values. And the opposite column represents the weights. Okay, so rather than using the formula, I could multiply across, add those up, and then again divide by the sum of the weights. However, I'm going to use the calculator for this one and enter these values into list 1 and list 2 in my calculator. Okay, I've entered those into list 1. The grades went into list 1 and the weights went into list 2. I go to Stat, over to Calc, 1var Statistics, and list 1 and list 2, and calculate. So this is exactly the same thing that we did basically when we were calculating the mean, median, mode, and mid-range for a frequency distribution. Okay, we get an average grade of 85.5%. Okay, so there are 3 shapes of graphs. I had mentioned symmetric when we had completed the one example and we saw all of the measures of center were approximately the same value. That's what we call a symmetric distribution. Also, you could see this referred to as normal, bell-shaped, mound-shaped. This is when the mean, the median, and the mode are all exactly the same and they're in the center of the distribution. Now, we could have a positive skew. A positive skew is when most of the data values are low, but we have a few data values that are really high in comparison to the rest. So it's pulling that right tail of the distribution out further. Those really high values are going to affect the mean. So it's going to pull the mean towards those high values. So the mean is going to end up being greater than the median and greater than the mode. The mode is always at the peak of the distribution. It's the number that occurs the most, so it has the highest frequency. The median is pretty unaffected by any extreme values, so it's going to stay in the center. A negative distribution or a negative skew or a left skew is going to do the exact opposite as what the positive skew did. So these few low values in comparison to the rest are pulling down the mean. And then the mode again is at the peak, which is more towards the right of the distribution. And the median stays in the middle. So the mean is less than the median, which is less than the mode in a negative skew distribution. So those are the three main types of shapes that we see in statistics, and the three that we're going to need to be familiar with in this unit. All right, so just some thoughts about the measures of center. We said a second ago that the mean is affected by extreme highs or lows or skews. So it's going to be affected by outliers or weights or skews. But it is the most useful measure when the data is symmetric. The median stays relatively unaffected by extreme highs or lows or outliers. And it would be used if we had an open-ended frequency distribution. In other words, if the frequency distribution said something like 20 and up. So that kind of indicates that we have an outlier in the data set. The mode is really only used if we have qualitative data. In other words, we have categories instead of numbers. So if we're talking about eye color, for instance, we can't find an average eye color. We can't find a median eye color. Makes no sense to find those two measures of center. Really the only one that makes sense is the mode. So which eye color is appearing the most? All right, this next slide is just a U-try. So take a moment, take a look at these three data sets. We have just a list of data for number 1. We have an ungrouped frequency distribution for number 2. And for number 3, we have a grouped frequency distribution. Find those measures of center, pause the video here, and then unpause, and I'll review the answers in just a moment. Okay, if you've completed those three, here are the results. Number 1, the mean is 6.375, the median 5.5, the mode is 3, and the mid-range is 7.5. For number 2, the mean was 1.25, the median was 1, the mode was also 1, and the mid-range 1.5. For number 3, the mean is 69.73. The median class is from 64.5 to 69.5. The modal class is 64.5 to 69.5 also, and the mid-range is 67.